Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. We're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 3.45. The problem statement says, an inclined manometer is a useful device for measuring small pressure differences. The formula given in section 3.4 for the pressure difference in terms of the liquid level difference, H, remains valid. But while H would be small and difficult to read for a small pressure drop if the manometer were vertical, L can be made quite large for the same pressure drop by making the angle of inclination theta small. Part A, derive a formula for H in terms of L and theta. So here I've got the diagram that they gave to us, and you can see we've got our equation here, H, is still valid. So we still have our pressure equals the reference pressure plus rho GH. That's still valid. We just need to put H in terms of L and theta, like it was saying. So this shouldn't be too hard. If you've taken trigonometry, you understand the relationship between triangles and angles and the lengths of the various sides of the triangle. Okay. So here we've got our triangle here. We've got H, we have our angle theta, and then we have this hypotenuse, which is L. So we know from trigonometry that the sine of theta is equal to the opposite, which is H, over the hypotenuse, which is L. Then we can rearrange this equation so that we have H equals L sine theta. All right, and that is it for part A. We now have H in terms of L and theta. Okay, now for part B, suppose the manometer fluid is water. The process fluid is a gas. The inclination of the manometer is theta equals 15 degrees, and a reading L equals 8.7 centimeters is obtained. What is the pressure difference between points 1 and 2? Or basically, what's the pressure difference across the manometer? Well, we know that pressure 1 side is a little bit more pressure than pressure 2 side because the liquid level is lower in the left side. Okay, so pressure 1 is equal to pressure 2 plus the difference in liquid height. Well, we know that H from before is equal to L sine theta. So the pressure difference, we just move P2 over to the other side, and we substitute our value for H that we got before, and they said it was water, so we just look up our values here. They gave us L, we put it in terms of meters, and you might need to change, just be careful when you're using degrees, you might need to change it into radians, just when you're doing your calculation, make sure you're using the correct units. And I got that the pressure difference is equal to 220 pascals, which is a pretty small pressure, and so it makes sense that you'd be able to see this pressure difference even with water as the manometer fluid. Or probably it's better to use water as a manometer fluid because it moves a little more than mercury would, so that H difference will be larger. So, yeah. All right, well that is it for problem number 3.45. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.